All right, welcome to Mod 6, Lesson 2. In this lesson objective, we'll be able to construct a coordinate system on a plane. Now, Lesson 1, we did a coordinate system on a line, but now we're actually going to be dealing with a plane. Okay, not the flying part, but just a plane surface. Now, the essential question, how can I use what I know about a line to construct a coordinate system? All right. Now, this is that long standard we're working with, MASS 5G11. Use a pair of perpendicular lines called axes to define a coordinate system with an intersection of the lines, which is called the origin, and arranged to coincide with 0 on each line and given a point of line located by using an ordered pair of numbers called as coordinates. Now, I'm not going to go through the rest of it, okay? Now, basically, we're just setting up a coordinate system, and we're going to be able to identify and plot coordinates on that system. Okay, so let's go ahead and get started. Now, first one, definition. A plane. It's a surface in which if any 2 points are chosen on a straight line joining them lies wholly in that surface. In other words, we've been going just horizontally on a line. Now we're going to end up we're adding another dimension to it instead of just having length. Okay, think of it like when we're doing volume. Initially, all we had was length. Then when we went to height, we added a second dimension. We added height to the length. And that's what basically we're doing with a coordinate system. So let's see what we're talking about here. You'll see what we're talking about here in a minute. All right, so as you can see, we have a line just like we did in lesson 1. And we know that line is horizontal, and that's our x-axis. And it shows us how far something is away from the origin. Now, that makes it very easy. It's like using a ruler. It's a linear measurement. It's a straight line, and we can see that that blue star is actually 4 units away from the origin. Now, we can measure many things with a ruler, but it's always in a straight line. What if it's not on that line? Now, this is where we got to create a plane, a coordinate plane. Okay, it's kind of like a map if you think of. If we were trying to identify a city on a map, not everything's going to be on a line. The origin would kind of be like where you're at. Okay, so in order to identify where that red star is at, we need to include a y-axis. Now that y-axis is a perpendicular line, which means it has a right angle to the x-axis. Okay, and the y-axis also has increments on it, and I've cut them in halves so that we can identify how high it is from the origin. Okay, so now let's try to identify how we could say where that red star is at. And we do that by coming over on the x-axis, and we can see that it's still over 4. And if we look on the y-axis, we can see that it's up 5 units from the origin on the y-axis. Now we can develop what they call a coordinate pair. Okay, a coordinate pair is always a list, and it has the x measurement first and the y measurement second. So for the red star, we can see we came over 4 on the x-axis, and then we went up 5 on the y-axis. So the coordinate pair for this would be 4, 5. Now this works because we always know the x comes first. Just like in the alphabet, x comes before y. So your x coordinate is always going to be first. And so now we have our red star identified. Now, what about that blue star? When we were talking about on a line, it said it was 4. But now that if we're talking about coordinate plane, how would we say the coordinate pair for the blue star? Think about it for a minute. How far over did we come on the x-axis? How far up did we go on the y-axis? Now, this is where students get a little confused sometimes. You can see very easily we came over 4 on the x-axis, but the y-axis, we didn't come up any. So the coordinate pair for that blue star would be 4, 0. Okay? Makes sense? All right, let's see if we can apply this a little bit. All right, now we're going to apply some of this. I don't expect you to draw the whole grid, okay? Just kind of take notes. Some of you will draw it anyway, and that's okay. But I just don't want you to try to spend a lot of time drawing the grid, all right? But you do what you want to do with your notes, okay? Now, let's start off with applying this. We're going to sit there and be looking for different components here. And I'm going to start here. It says smiley face. So I'm going to go over here. I'm going to highlight it so you can see where it's at. There's our smiley face, okay, in yellow. Now we're wanting to find the coordinate pair for it. So the x coordinate we come across, we see how far on the x coordinate did it go. And you should say that it came over 2 places. So our x coordinate would be 2. Now we want to know how high did it go on the y-axis, okay? And we can tell that by looking over here. We can see that it came up 1. So our y coordinate would be 1. So our coordinate pair would be 2, 1. All right, let's do a green this time. This time we're looking at the diamond up here, and I'm highlighting it in green. So think for a second, and I want you to try to find the coordinate pair for it. If you want to pause it for a second, go ahead. All right, now I can see that it came across 2, just like our smiley face. So our x coordinate would be 2. Now, if I'm looking for my y, which is how high, I'm going to come across here and see what this unit is right here. And I can see this is between 3 and 4. And I have 3.5 underneath of it. So first thing I need to do is identify how many units are in between. So if I started at 3, count up, I got 1, 2, 3. They're split up into 4 sections in between 3 and 4. So I know each one's going to be a quarter. So this here would be 1 quarter, 2 quarters, and the sun would be at 3 quarters. So I can see that the coordinate now would be 3 and 3 quarters. And that makes our coordinate pair 2, 3 and 3 quarters. All right, so let's move on. This time let's try the sun. And the sun, which is up here, and we're going to do that one in yellow also because the sun is usually yellow. So there it is. Now this is one of the ones where the students get confused a little bit because the first question is how far over on the x-axis did it move? Well, this really bothers some students because if I look at my x-axis here, which is running this direction, it didn't move any. So that means it remained at 0. Okay. Now we want to see how high it came, and we can see that it's on the same line that we had our diamond. So we know this would be 3 and 3 quarters. So the sun would actually be 0, 3, and 3 quarters. Okay, our last one. Our last one's a heart. Hearts, they always show them, oh, I wanted wrong color, because they usually show hearts for Valentine's Day and everything. They're always red. So there's our heart. Okay. Now let's look at the x-axis. How far over did it come on the x-axis? Well, we already know our grids are in quarters. So if I start at 3, I know that's 1 quarter, 2 quarters, and this one here is 3 quarters. So it's going to be 3 and 3 quarters. Now, looking at our y-axis, how high did the heart go? Well, the heart didn't move from the x-axis. So that means it's a 0. So our coordinate pair for the heart would be 3 and 3/4 and 0. Okay, so that's if we had to create ordered pairs given symbols on a coordinate grid. Now let's try a little differently. What if they gave us the coordinates and they wanted us to tell the shape? Remember, you don't have to draw this. I'm just work along with me. Okay. Take any notes you think that are important. Now let's start first at coordinate 2, 4. So that's telling me to go over 2 and up 4. Okay. Talking about this one right here. So if I look at my coordinate grid and I come over 2 and then I go up 4, I can see that I have the circle. I'm going to go ahead and put a circle in there. Okay. Now I'm going to go red this time so we can keep track of it. Next one said come over 5. Remember, you always do X first. And now I'm going up 4. And what is that called? Who's that a diamond? It's a rhombus. Okay. So here's our rhombus. And it's colored in a little bit. Got to have a little fun coloring in. There we go. So our rhombus would be 5, 4. All right. Now our next one. Over 1, up 5. And what is that? If you said a quadrilateral, you're wrong. It's a triangle. Okay. Remember, quadrilateral has how many sides? 4. Our triangle only has 3, but it is a what? It's a polygon. That's right. Okay. Now our last one. Let's see what pretty color. Purple. Let's do purple. Okay. The last one said go over 5 and up 1. And we can see that our final one would have been the heart. Okay. All right. So that's it for this one. Let's take a look at the next couple questions. Which shape is 2 units from the x-axis? Now, in this one here, we're not asking anything about the y-axis. Just want to know which one is 2 units from the x-axis. Now, this is another one where some people get confused. It didn't ask 2 units on the x-axis. It wants to know from the x-axis. So anything that is 2 units from the x-axis. So as you can see, the only thing, 2 units would be right here. So 2 units from the x-axis, that would be the star. Because I didn't ask if it was 2 units on the x-axis. It's from the x-axis. All right, let's look at C. Which shape has the same x and y coordinate? So we're looking for a shape that has the same x and same y. Which one is it? Hopefully what you said was the square, because a square has a coordinate of 3 on the x-axis, 3 on the y-axis. All right, so that's it for this lesson. Lesson 1, we used a line, and we sit there and split it up into intervals, and we were seeing how far along something went on the x-axis. In lesson 2, we added a y-axis, which is perpendicular. And that gave us the ability to come up with a coordinate pair. And remember, it's very important that x always comes before y. Okay? All right. Have a good day. Hopefully, we'll see you in school soon.